Hello friends, welcome back to my channel iTech Share. You might already aware that we are going through design pattern and design principle series. We have discussed so many things on the design patterns and today is that day to get into design principles. Today I am going to discuss about one of the most widely used principle, that is solid principles. This is the most widely used principles where every letter of the word solid represent one principle. So do watch this video till the end and in next few minutes you will become a pro in solid principles. Solid principles is for object-oriented design. Whenever you are going to design something using object-oriented programming technology, you should follow this pattern. It will help you to make your code much maintainable and sustainable. Several times, as a code reviewer, you might think what could be a good design guidelines. Here I am not talking about syntax. It's all about the solution approach. If you will follow solid principles, by default your code will become high quality. So this should be must-have review items in your bucket list. You can see here that here S represent single responsibility principle, O for open close principle, L for list of substitution principle, I for interface segregation, and last but not the least, D for dependency inversion principle. In next few slides, I'll go in deep for each and every categories. Please stay tuned. Happy coding, happy learning. Single responsibility is something where we are talking about do one thing at a time. And don't overcomplicate the things by adding too many things handled by a single class. Your code will be much more maintainable in such cases where you will have single responsibility per class. In modern programming world, everyone is talking about microservices. The essence behind microservices is also the same. If you have multiple operations to do like add, edit or update or delete, create different service component for each operation rather than putting all in one. You can see in this employee class, there are three methods like print descriptions, finance descriptions, and admin descriptions. And three of them almost doing the same thing, but for different types of employees. Print description is for the common employees, let's say for employee print descriptions. I mean, the things that is printing over here. Then finance descriptions is printing the things for the finance employee, and for admin people is getting printed under admin description. Correct? Single responsibility pattern says that don't do like this. If you want to do multiple things like for multiple types of employees, segregate it in different classes. Like for your common employee class, it can be only have print descriptions, and then for your finance description, you can have one finance class, finance employee class. Inside that you can have this implementation. Similarly for admin types of people, you can have another separate class, and underneath that you can have admin description. The second pillar of solid principles is open close principles. That means your class should be open for extension but closed for modification. What does it mean? Let's have a look in the coding. So here you can see the same example that we have discussed under first principle, the employee class, which is having three methods like print description, finance description, and admin description. Let's say tomorrow there is another requirement change, and this time they are asking you to write something for HR employees. What you need to do? You need to go ahead and change this employee class and need to provide implementation for HR employee too. Now, if any derived classes using this employee class, those classes might also get impact due to this change. Too complicated, no? Because every day or every time there are some changes, you need to go ahead and update this employee class, and then there should be some cascading effects. To avoid these things, the best possible way to implement these things, if you follow this open close principle through abstract class, right? And what abstract class says, that your abstract class should not have any implementation, just the declaration. Like here you can see that abstract void print descriptions, and any classes which are going to implement this class, abstract class, they need to provide implementation as per the requirement. Let's say here for finance employee, when it's deriving that employee class, it's having their own implementation under this print description. Similarly for admin employee, and then so on and so forth for HR employee or any types of employees, right? So it's as simple as that. To clear this idea, you can watch my video on this virtual method or abstract class or interface, which I have posted, I think 1 month back in my YouTube channel. So here also you can see how we can achieve this same thing using this virtual method or interface or abstract class, right? So if you follow any of these things, you can able to achieve these open close principles. Okay, so bottom line is that don't modify your base class, but make it such a way that it can be extensible. The third pillar of solid principles is the list of substitution principle, which is little bit complex if you'll go by the definition. As per the definition, the subclass or derived class should be substitutable for their base or parent class. If the child object is replaced with the parent, the behavior should not be changed. But guys, I'm just suggesting you don't go by with this definition. Go ahead and implement your factory pattern, and that is all about list of substitution. So here you can see in my channel, I already published one full video on factory pattern. You can have a look. You'll get the clear idea how to implement list of substitution. Next pillar is little bit simple to understand. It's interface segregation. And what it says that many client-specific interfaces are better than one general-purpose interface. General tendency for every programmer to club everything inside one interface. So it says, no, don't do that. Just segregate it. Let's take one example. Let's take this example. In this interface A, you can see that it's having three methods. I mean, three definitions for add user, add product, and add payment. And whenever this user class is going to implement these things, maybe payment class or maybe product class, for all these three classes, this is now mandatory to implement these three methods, right? These three methods. But why then this user class is going to implement for add product or maybe for add payment? Similarly for payment class, I mean, user or product related things is not relevant, and same thing for product. So here you can see this is generic interface that we have developed, and that's why this user class, payment class, and product class need to implement all these methods. So in this case, what is it telling? That go ahead and segregate this interface like interface A, interface B, and interface with the relevant method inside, like add user, add product, or add payment. And then whenever you are going to implement for a specific class, go ahead with this interface. Rather than going for a general interface, just segregate it depending upon your requirement. That's all about interface segregation. Guys, the last and the fifth pillar of this solid principle is the dependency inversion, where we talk about decoupling of our software modules. I have a detailed video on dependency injection in my YouTube channel. Do watch that video where I have described about various ways to implement this dependency injection. So guys, that's all for now. I hope you enjoyed this session too. And I'll be coming with another session very soon. Till the time, stay tuned. And before concluding these things, please do subscribe this channel if not yet done. Thanks for your time. Thanks for your patience.